Okay, so hello, welcome back. So the next part of this chapter is basically exercise 3.2, which is a couple of exercises on matrices, what we have done so far. Exercise 3.2, and that is basically, so you have three matrices A, which is basically 2, 4, 3, 2. You have another matrix B, which is 1, 3, negative 2, 1, 3, negative 2, 5. Another matrix C, which is negative 2, 5, 3, 4. And you want to calculate, for example, A plus B. So to calculate A plus B, you can write 2, 4, 3, 2. And B is basically 1, 3, negative 2, and 5. And then you can add them together. The corresponding elements 2 plus 1, and 4 plus 3, and 3 plus negative 2, and 2 plus 5. And then you can add these together as 3, 7, 3 minus 2 is equal to 1, and that's 7. So that is basically A plus B. Now A minus B is the same thing as the same thing. So 2, 4, 3, 2 minus 1, 3, negative 2, 3. That's a 5 actually. That is a 5. Okay. And then I can write this as basically 2, 4, 3, 2. 2, 4, 3, 2. And add it to the negative of this matrix. Meaning that negative 1, negative 3, positive 2, negative 5. And therefore I will have basically 2 plus negative 1, 4 plus negative 3, 3 plus 2, and 2 plus negative 5. And then you have 2 plus negative 1 is equal to 1, 4 minus 3 is equal to 1, 3 plus 2 is equal to 5, and 2 minus 1 is equal to negative 3. That is A minus B. Now if you want to calculate, for example, 3A minus C, 3A minus C is equal to 3 times A, which is equal to 2, 4, 3, 2. And C is basically this matrix here, negative 2, 5, 3, 4. And that is equal to, multiplying this matrix, you'll get 3 times 2 is equal to 6, 3 times 4 is equal to 12, 3 times 3 is equal to 9 and 6. And then I can write, instead of minus, I can write plus the negative of this matrix, 2, negative 5, negative 3, and negative 4. And therefore I will have 6 plus 2, 12 plus negative 5, 9 plus negative 3, and 6 plus negative 4. And that is equal to 8, 7, and 6, and 2. So that is basically 3a minus c. 3a minus c. Now if you have a times b, or ab, a was equal to 2, 4, 3, 2, and then you have 1, 3, 1, 3, negative 2, and 5. That is b. So to multiply, you can take this row and this column, and this is a 2 by 2 matrix. This is 2 by 2 matrix, so you get a 2 by 2 matrix. So 2 times 1 is equal to 2, and 4 times negative 2 is equal to negative 8. Then going to this column, you get 2 times 3 is equal to 6. 4 times 5 is equal to 20. Then moving to this column, you have 3 times 1 is equal to 3, 2 times negative 2 is equal to negative 4. And moving to this column, you have 3 times 3 is equal to 9, and 2 times 1 is equal to 10. So you have 2 plus negative 8 is negative 6, that is 26, that is negative 1, and 19. Now b times a is equal to 1, 3, negative 2, and 5, and a is 2, 4, 3, 2. Which is equal to, I can start from this row, this column, so 2 by 2 matrix, 1 times 2 is equal to 2, 3 times 3 is equal to 9. Moving to this column, 1 times 4 is equal to 4, 3 times 2 is equal to 6. Moving to this row, this column, I'll have negative 2 times 2 is equal to negative 4, plus 5 times 3 is equal to 15. And moving to this column, you have negative 2 times 4 is equal to negative 8, and 5 times 2 is equal to 10. So that is equal to 11, 10, 15 minus 4 is equal to 11, 10 minus 8 is equal to 2. So that is b times a. There are a couple of matrices here that are typical matrices that you could probably learn if you want to. Question number 2, you want to compute, for example, AB, negative BA, and AB negative A, and ABBA. Okay, so I can write it as, for example, this row, this column, I'll have a squared plus b squared. This row, this column, I'll have ab plus ab, which is ab plus ab. This row, this column, which I will write in this color. This row, this color, this row, this column, I'm sorry, that's negative ab plus ab. And this column would give me negative b squared plus a squared. And that is equal to basically a squared plus b squared, 2 times ab, that is 0, and then a squared minus b squared. For example, that is that. Or if you have, for example, a squared plus b squared, and here you have b squared plus c squared, and here you have a squared plus c squared, and here you have a squared plus b squared. This is one matrix. And if you want to added to, oh, that was actually, this one was actually addition. So we will do it again afterwards, okay? So this is 2 times AB, this is 2 times BC, this is negative 2 AC, and this is negative 2 times AB. So I can write this as A squared plus B squared plus 2AB, A squared plus B squared plus 2AB. This is B squared plus C squared plus B squared plus C squared plus 2 times BC. This is A squared plus C squared minus 2 times AC. This is A squared plus B squared minus 2 times AB. And that's the same thing as A squared plus B squared plus 2 times AB is equal to A plus B whole squared. B squared plus C squared plus 2 times BC is equal to B plus C whole squared. A squared plus C squared minus 2 times AC is equal to A minus C whole squared. And A squared plus B squared minus 2 times AB is equal to A minus B whole squared. That is going to be your matrix. Now about this one, you have AB negative BA, and if you add it to the next matrix, which is AB BA, is equal to 2A, A plus A, and 2B, and 0, and 2A. Okay. Or if you have, for example, something like negative 1, 4, for example, negative 6, 8, 5, 16, 8, 5, 16, 2, 8, 5, 2, 8, 5, and add it to 12, 7, 6, 12, 7, 6, 8, 0, 5, 8, 0, 5, 3, 2, 4, and if you add them together, you'll get negative 1 plus 12 is equal to 11, 4 plus 7 is equal to 11, 6, negative 6 plus 6 is equal to 0, 8 plus 8 is equal to 16, 5 plus 0 is equal to 5, 6 plus 5 is equal to 21, 16 plus 5 is equal to 21, 2 plus 3 is equal to 5, 8 plus 2 is equal to 10, and 5 plus 4 is equal to 9. Or if you have cos squared x, and here you sine squared x, and here sine squared x and cos squared x, if you add that to sine squared x, cos squared x, cos squared x, sine squared x, that's the same thing as cos squared x plus sine squared x, sine squared x plus cos squared x, sine squared x plus cos squared x, cos squared x plus sine squared x, which is, you know that cos squared x plus sine squared x is equal to 1. So this becomes basically 1, 1, 1, 1. Okay? That was question number 2. Question number 3. Compute the indicated products. So you have, for example, okay, so question number 3, the part 1 we already, I think we have, no we haven't. So question number 3 is basically you have a couple of products that you want to compute, for example, AB negative BA, and you want to multiply that by A negative B BA. So to calculate this is a basically 2 by 2 matrix. This is a 2 by 2 matrix, so you'll get a 2 by 2 matrix. Starting from this row, this column, you'll get a squared plus b squared. And this column and this row, you'll get negative ab plus ab. And then this row and this column, you will get negative ab plus ab. And this row and this column, you'll get negative positive b squared plus a squared, which is the same thing as a squared plus b squared, 0 and 0, and a squared plus b squared. So that is that. Okay, so for example, let's say that we have 1, 2, 3 as a column matrix, and I have 2, 3, 4, for example, as a row matrix. So this is a 3 by 1 matrix, this is a 1 by 3 matrix, which means that I will get a 3 by 3 matrix, right? So it means that this row by this column is going to be 1 times 2 is equal to 2, 1 times 3 is equal to 3, 1 times 4 is equal to 4, 2 times 2 is equal to 4, 2 times 3 is equal to 6, 2 times 4 is equal to 8, 3 times 2 is equal to 6, 3 times 3 is equal to 9, and 3 times 4 is equal to 12. Right? So that is that. Let me put these answers up here. Okay, so that was basically part 2. Part 3 of this question. This is part 3 of question number 3. Is basically 1 negative 2, 2, 3 is 1 negative 2, 2, 3 times 1, 2, 3, 2, 3, 1. 1, 2, 3, 2, 3, 1. And that is equal to basically, this is a 2 by 2 matrix, this is a 2 by 3 matrix, so I'll get a 2 by 3 matrix. So this row times this column is 1 times 1 is equal to 1 plus negative 2 times 2 is equal to negative 4. And then you have this row times this column, 1 times 2 is equal to 2, negative 2 times 6, 3 is equal to negative 6. And then you have times this column, you have 1 times 3 is equal to 3, negative 2 times 1 is equal to negative 2. And then you have this row times this column is 2 times 1 is equal to 2 plus 6. Then you have 2 times 2 is equal to 4 plus 3 times 3 is equal to 9. And over here you have 2 times 3 is equal to 6 plus 3. Which is equal to negative 3, negative 4, 1, 8, 13, and 9. So part 3 of question number 3 is negative 3, negative 4, 1, 8, 13, and 9. Part 4 of this question is another matrix, which is 2, 3, 4, 3, 4, 5, 4, 5, 6 times 1, negative 3, 5, 0, 2, 4, 3, 0, 5. So 3 by 3, 3 by 3, so you'll get the 3 by 3 matrix, of course. 2 times this row times this column, you'll get 2 times 1 is equal to 2, 3 times 0 is equal to 0, 4 times 3 is equal to 12. Then you have this column, 2 times negative 3 is equal to negative 6, plus 3 times 2 is equal to 6, plus 4 times 0 is equal to 0. This column, you have 2 times 5 is equal to 10, and 3 times 4 is equal to 12, and 4 times 5 is equal to 20. So then this row, this times this column, you'll get 3 times 1 is equal to 3, 4 times 0 is equal to 0, 5 times 3 is equal to 15. This column, 3 times negative 3 is negative 9, 4 times 2 is equal to 8, and 5 times 0 is equal to 0. This column, you have 3 times 5 is equal to 15, 4 times 4 is equal to 16, 5 times 5 is equal to 25. 4 times 1 is equal to 4, 5 times 0 is equal to 0, 6 times 3 is equal to 18. This column, negative 12, basically 5 times 2 is equal to 10, and 6 times 0 is equal to 0. And this column, 4 times 1 is equal to 20, 5 times 4 is equal to 20, and 6 times 5 is equal to 30. And there you have basically 12 plus 2 is equal to 14, 0, that is 20, 30, 40, 42. Then you have an 18 here, you have 7 there, you have 25 plus 15 is equal to 40, 56, 18 plus 4 is equal to 22, 20, I'm sorry, that's a 10, 10 minus, that's a negative 2, and that's a 40 plus 30 is equal to 70. So there you have part 4 of this question, which is 14,042, 18, negative 156. That's supposed to be a negative 1. So this is the second row. This one is, there is a problem here. 56 and 22, negative 2 and 70. So this one comes from here, which means that you're at basically the second row, second column. Second row, second column means that 3 times negative 3 is equal to, that's a negative 9. Negative 9 plus 1, I actually misread that my own number. That's a negative 9 plus 8 is equal to negative 1, of course, which is the correct answer, right? So that's part 4 of this question. Now part 5 of this question is 2, 1, 32, 32, negative 1, 1, and 1, 0, 1, 0, 1, negative 1, 2, 1. That's a 3 by 2 matrix. That's a 2 by 3 matrix, meaning that you get the 3 by 3 matrix. So this row, this column, you'll get 2 times 1 is equal to 2, 1 times negative 1 is equal to negative 1. Then you have basically 2 times 0 is equal to 0, and 1 times 2 is equal to 2. And then you have basically 2 times 1 is equal to 2, and 1 times 1 is equal to 1. Then you have this column times this row times this column. 3 times 1 is equal to 3. 2 times negative 1 is equal to negative 2. 3 times 0 is equal to 0. 2 times 2 is equal to 4. And this column is 3 times 1 is equal to 3. And 2 times 1 is equal to 2. This row and this column, negative 1 plus negative 1. And then you have 0 plus 2. and then you have -1 plus 1, which is equal to basically 2 minus 1 is equal to 1, 2, 3, 1, 4, 5, -2, 2, and 0. So part 5 is 1, 2, 3, 1, 4, 5, -2, 2, and 0. This is a -2, of course. Part 6 of this question. Part 6 of this question is 3, -1, 3, -1, 0, 2, and there you have 2, -3, 1, 0, 3, 1. This is a 2 by 3 matrix. This is a 3 by 2 matrix, so I'll get a 2 by 2 matrix. Now this row times this column is equal to 3 times 2 is equal to 6. -1 times 1 is equal to -1. And 3 times 3 is equal to 9. Then this row times this column gives you 3 times -3 is equal to -9. And -1 times 0 is equal to 0. And that's a 3. Then you have this row, this column, so that's a -2. 0 plus 6. That's a +3 plus 0 plus 2. And then you have 15 minus 1 is equal to 14. -9 plus 3 is equal to -6. 6 minus 2 is equal to 4. You have a 5 here. So part 6 of this question is basically 14, -6, 4, 5. That was question number 3. Question number 4, you have basically you have 3 matrices A, B, and C. A is 1, 2, -3, 5, 0, 2, and 1, -1, 1. And B is a matrix as basically 3, -1, 2, 4, 2, 5, and 2, 0, 3. And then C is a matrix as 4, 1, 2, 0, 3, 2, 1, -2, 3. And so you want to compute A plus B and B minus C. So A plus B is equal to basically these two matrices added together, meaning 1 plus 3 is equal to 4, 2 plus -1 is equal to 2 minus 1, which is equal to 1, -3 plus 2 is -1, 5 plus 4 is equal to 9, 0 plus 2 is equal to 2, 2 plus 5 is equal to 7, 1 plus 2 is equal to 3, -1 plus 0 is equal to -1, and 1 plus 3 is equal to 4. And also you want to compute B minus C. So you can basically B minus C, you can you can just simply subtract, meaning that you can say 3 minus 4 or 3 plus -4, which is the first matrix plus the negative of the second matrix. That's basically the same thing, whichever one you do. So 3 minus 4 is equal to negative 1, negative 1, negative 1 is equal to negative 2, 2 minus 2 is equal to 0, 4 minus 0 is equal to 4, 2 minus 3 is equal to negative 1, 5 minus 2 is equal to 3, 2 minus 1 is equal to 1, 0 minus negative 2 is equal to positive 2, and 3 minus 3 is equal to 0. And now we want to verify that a plus b minus c is the same thing as a plus b minus c. A plus b minus c. And we call this the associative but the associative law of addition, right? We call this the associative law of addition. This is nothing but the associative law of addition, although there is subtraction, which is the same thing as addition, meaning that when you're subtracting, you're actually adding, but adding the negative of the other matrix. So it's basically the same thing. So this is called the associative law of addition. Right? So if you want to basically verify this, so a plus b minus c would therefore be, so this is b minus c and this is a, and you want to add these two together. This would be basically 1 plus negative 1 is equal to 0, 2 plus negative 2 is equal to 0, negative 3 plus 0 is equal to negative 3, 5 plus 4 is equal to 9, 0 plus negative 1 is equal to negative 1, 2 plus 3 is equal to 5, and 1 plus 1 is equal to 2, negative 1 plus 2 is equal to 1 basically, and 1 plus 0 is equal to 1, right? And and also a plus b minus c is the same thing as this is a plus b, and you want to subtract this one from this one, which means that 4 minus 4 is equal to 0, 1 minus 1 is equal to 0, negative 1 minus 2 is equal to negative 3, and 9 minus 0 is equal to 9, 2 minus 3 is equal to negative 1, 7 minus 2 is equal to 5, 3 minus 1 is equal to 2, negative 1 plus 2 is equal to negative 1 minus negative 2, which is negative 1 plus 2, which is equal to negative 1 plus 2 is 2 minus 1, which is equal to 1, and 4 minus 3 is equal to 1. And therefore, you can see that basically a plus b minus c is equal to a plus b minus c. That is basically the associative law of addition. So that is basically that. That was question number 4. Now question number 5 is, you have A is equal to this matrix as 2/3, 1 5/3, 1/3, 2/3, 4/3, 1/3, 2/3, 4/3, 7/3, 2 2/3, and B is basically another matrix, 2/5, 3/5, and 1, 1/5, 2/5, and 4/5, and 7/5, and 6/5, and 2/5. You want to compute 3a minus 5b. 3a minus 5b. So that is equal to 3 times a, which is basically, I will write the matrices again. So that is 2/3, 1/5, 1/3, 2/3, 4/3, 7/3, 2 and 2/3, minus 5b, minus 5 times b, which is basically 2/5, 3/5, 1, 1/5, 2/5, 4/5, 7/5, 6/5, and 2/5. And by multiplication, we'll have basically 3 times 2/3 is equal to 2. 3 times 1 is equal to 3. That's equal to 5. That's equal to 1. That's equal to 2. That's equal to 4. That's equal to 7. That's equal to 3 times is equal to 6 and 2. And minus basically 5 into basically 5 times 2/5 is equal to 2, 3, 5, 1, 2, 4, 7, 6, and 2. And now I can write this as, you can subtract, you can, or add the negative of this matrix. I'll just simply subtract. 2 minus 2 is equal to 0, 3 minus 3 is equal to 0, 5 minus 5 is equal to 0, 1 minus 1 is equal to 0, 2 minus 2 is equal to 0, 0, 0, 0, and 0. Let's say 0 matrix, which is equal to O. That was question number 5. Question number 6 is, you want to simplify cos theta times, you want to simplify cos theta times cos theta sin theta, negative sin theta, and cos theta, and that plus sin theta times sin theta, negative cos theta, and cos theta sin theta. Okay, so this is equal to, basically this is just scalar multiplication, so that is cos squared theta sin theta cos theta. Now this is negative sin theta cos theta, and this is cos squared theta, and then you have plus sin squared theta, negative sin theta cos theta, sin theta cos theta, and sin squared theta. And if you add the two together, what you will get is basically cos squared theta plus sine squared theta. So you have sine theta cos theta and negative sine theta cos theta. That's going to be equal to 0. Write it as 0. So negative sine theta cos theta plus sine theta cos theta is 0, and cos squared theta plus sine squared theta is equal to 1 actually. So that is equal to basically 1, 0, 0, 1. Let's say that's an identity matrix of order 2. That's equal to I. Right. Okay, so that was question number 6. Question number 7 is you have some equations that you want to solve for x and y. Okay, so the equation that we have is basically question number 7 is you want to find, there are basically you want to find x and y. You want to find x and y if x plus y is equal to 7, 0, 2, 5, and x minus y is equal to 3, 0, 0, 3. So now if I write, basically if I add both sides of these two equations together, I get x plus y, and added to this, basically I'll get plus x minus y is equal to 7, 0, 2, 5 plus 3, 0, 0, 3, and y minus y is the same thing as, so basically what I could do is that I could write this as x plus y, and then basically since addition of matrices are commutative, I can write this as negative y plus x, and y minus y is equal to the 0 matrix, so I can write this as x plus o plus x. And again, I can write this as x plus o, and so that is 2x plus o, and 2x plus o is equal to 2x, right? So that is basically, and that is equal to basically the sum of these two matrices, which is 7 plus 3 is equal to 10, 0, 2 plus 0 is equal to 2, and 5 plus 3 is equal to 8. And now divide both sides of this equation by 2, I will get x is equal to 1/2 times this matrix, which is 10, 0, 2, 8. And that gives me basically x is equal to 1/2 times 10 is equal to 5, 0, 2 times 1/2 is equal to 1, and 8 divided by 2 is equal to 4. So that is x. Now since I know what x is, I can use it here and write this as, for example, since I know that basically x plus y, for example, x plus y is equal to 7, 0, for example, 2, 5. Now x is basically this matrix, and so over here y would be, if you want to get basically y on one side of the equation, you can write x plus y and subtract an x is equal to 7, 0, for example, to 5, and subtract the same x here. And then I can since addition is commutative, I can write this as x minus x plus y is equal to, again, the right hand side, and x minus x is equal to O plus y is again equal to the RHS. It is also the RHS, and y plus O is equal to O plus y is equal to y is equal to RHS, and your RHS is equal to 7025 minus x, and x is basically this matrix, which is 5014, which gives me basically y is equal to 7 minus 5 is equal to 2, 0 minus 0 is equal to 0, 2 minus 1 is equal to 1, and 5 minus 4 is equal to 1. So, which gives me basically x is equal to 5014, y is equal to 2011, and that was question number 7, part 1. Question number 7, part 1, 5014 and 2011. That is the correct answer. Part 2 of this question. Part 2 of this question is, again, you want to find basically, you want to find x and y, and you have basically 2x plus 3y is equal to 2340, and you have 3x plus 2y is equal to 2, -1, and 5. Right? Now, what I can do here is that probably, for example, calculate x somehow in terms of y, and then use it in the other equation. For example, I can say that, for example, 2x plus 3y is equal to the RHS of this equation. And then I can write 2x, actually I can write it this way as well to save more steps. So 2x plus 3y minus 3y is equal to basically 2340 minus 3x. I'm sorry, minus 3y it has to be. Minus 3y. Now, plus 3y minus 3y is equal to O. So that is 2x plus O is equal to 2340 minus 3y. 2x plus O is equal to 2x. So 2x is equal to 2340 minus 3y. That is a matrix. Which means that x is equal to 1/2 times 2340 minus 3y, and that is your x. Now you can put your x in this equation, and so meaning that you can write 3 times x. Instead of 3x, I'll write this basically this whole expression, which is 3/2 times basically 2340 minus 3y plus 2y is equal to basically 2, -2, -1, and 5. And that gives me basically, if I multiply this, I'll get 3/2 times 2340, and so that would be -9/2 y plus 2y is equal to 2, -2, -1, and 5. Now, negative 9 halves y plus 2y would be negative 9 halves plus 2 is the same thing as 2, so negative 9 and plus 4, so that's negative 5 halves. So I can write this as 3 halves times 2, 3, 4, 0, negative 5 halves y is equal to 2, negative 1, and 5. Right? Then what I can do is that I can say that I can take this to the other side of the, I can take this matrix to the other side, meaning that I can write, for example, add a negative 3 halves times the same matrix 2, 3, 4, 0. Add this to the same matrix plus 3 halves 2, 3, 4, 0 minus 5 halves y is equal to, and since I subtracted this matrix from this side, I have to subtract it from this side as well, meaning that I write 2, negative 1, 5, and subtract the same thing from here, meaning negative 3 halves times 2, 3, for example, 4, 0. Right? Now these two would be O, because this is the negative of this matrix, so I can write O minus 5 halves y is equal to 2, negative 1, and 5, and minus 3 halves 2, 3, 4, 0, and that is the same thing as negative 5 halves y is equal to basically 2, negative 1, 5. And if I calculate this side of this equation, I will get, I'll do that separately. Basically, I'll get 2, negative 1, 5. And if I multiply this here, I'll get negative, and then 3 halves times 2 is equal to 3. And that is 3 halves times 3 is equal to 9 halves. And 3 halves times 4 is equal to 12 halves, which is equal to 6. And that's a 0, right? And if I do this calculation, I will get basically 2 minus 3 is equal to negative 1, negative 2, negative 9 halves is equal to basically 2, negative 4, negative 9, which is negative 13 halves, negative 13 halves, negative 1 minus 6 is equal to negative 7, and negative 5 minus 0 is equal to 5. So instead of the whole right hand side, I can simply write this matrix, which is negative 1, negative 13 halves, negative 7, and 5. And then what I can do is multiply both sides of this equation by basically negative 2/5. Because negative 5 halves times negative 2/5 would be equal to 1, right? So this times negative 2/5 would be 1, so I will get a y, and then negative 2/5 times this matrix times to this matrix, negative 1, negative 13 halves, negative 13 halves, negative 7, and 5. And y is equal to negative and positive, so that is 2/5. Negative into negative is positive, and then you have basically negative 2/5 times negative 13 halves would be, these two will be cancelled, 13/5. So negative into negative is 14/5. 14 fifths, and then 5 and 5 cancel out, so you have -2. That is your y. Now since I have my y, I can calculate my x. So somewhere over here we had 2x plus 3y. We had 2x plus 3y is equal to 2340. 2340. Right? And y is 2 fifths, so I can write basically 2x plus 3y, 2x plus 3y minus 3y is equal to 2340 minus 3y, and this becomes O, and 2x plus O is equal to 2x, so 2x is equal to 2340 minus 3y, and y is equal to this, meaning that, and then x is equal to this times 1/2, so 1/2 of basically 2340 minus 3 times y. Y is equal to 2 fifths, 13 fifths, 14 fifths, and -2. And then you can calculate this pretty easily, meaning that you can write basically 2340, that's the same thing as, so x is equal to 1/2 times 2340 minus 3 times, so 3, I can multiply it. So that is basically 6 fifths. 6 fifths. That is 13 times is equal to 39 fifths. 39 fifths. 14 times 3 is equal to 42 fifths. And that's -6. And if I do this calculation, I will get so that is 2 minus 6 fifths is the same thing as basically 10 fifths minus 6 fifths is equal to 4 fifths. 3 minus 39 fifths would be 5, 3, 15 fifths minus 39 fifths. Now 39 minus 15 is equal to 24, so that's -24 15. -24. Actually, that's supposed to be a 5. That's 39 fifths, right? So 24, so that's -24 fifths. And 4 minus 42 fifths is equal to 5. 20 fifths minus 42 fifths, that's -22 fifths. And that is a +6, you already know that. So that's 1/2 times basically this matrix, which is, of course, this is not required anymore. 1/2 times basically 2 minus 6 fifths is equal to 4 fifths. 3 minus 39 fifths is equal to -24 fifths. And 4 minus 42 fifths is equal to -22 fifths. And that's a +6, which is equal to basically 1/2 times 4 fifths is equal to 4 divided by 2 is equal to 2. That's 2 fifths. And 24 divided by 2 is -12 fifths. And -11 fifths. and 6 divided by 2 is equal to 3. So that is your x. Your x is equal to this. So that means that x is equal to 2/5, negative 12/5, negative 11/5, and 3. And your y is equal to 2/5, 13/5, 14/5, and negative 2, which is correct. So that was question number 7. We will do the rest of these in the next video.